Good evening, one and all. So today we are going to discuss about flow measurement, flow rate measuring devices. So one of the flow rate measuring devices that is about rotameter. So flow rate is also called as a rate of flow or a discharge. Discharge means meter cube per, what are the units of the discharge? Meter cube per second. So how much volume of water is coming per second per minute? How much quantity of water? How much quantity of volume of water is coming per particular time through the given fluid pipeline. So we need to measure the flow rate or discharge by using rotameters. So the rotameters are simple industrial flow meters that measures the flow rate of liquid or gases in a closed tube. So simply we call it we need to measure the gases or liquid flow rate by using rotameter. So these rotameters are invented by Carl Kupers in the year of 1908. So rotameter is also known as the variable area meters. Rotameters is also known as a variable area meters. So here we need to change the cross sectional area. So that's why we call it as a variable area meters. So the rotameters measures the flow rate by allowing the fluid to travel through the tapered tube. So the description of the rotameter, it consists of a tapered tube. It consists of a tapered tube. So we need to change the cross-sectional area. So that cross-sectional area of the tube gradually increases as the fluid through the tube. So the rotameter measures the flow rate by allowing the fluid to travel through the tapered tube where the cross-sectional area of the tube gradually increases. So the rotameter measures the flow rate by allowing the fluid travel through the cross-sectional tapered tube where the cross-sectional area of the tube gradually increases of the fluid travels through the tube. So here, the basic principle, so this is the basic principle the rotameter works. The rotameter works and this is the principle. So this is the fluid by allowing the fluid to travel through a tapered tube. So here in the rotameter we have a tapered tube, so where the cross sectional area of the tube gradually increases. At the bottom will be narrow, at the top it will be wider. So we'll see in the image. So the bottom of the tube will be narrow and at the top of the tube will be wider, so that cross sectional area of the tube will be gradually increasing. So this is the principle the rotameter works. So the flow rate inside the rotameter is measured by using the float. So another important another important component of the rotameter, that is about float. So the flow rate inside the rotameter is measured by using float. So that is lifted by the fluid based on the buoyancy and velocity of the fluid opposing gravity pulling of the fluid into the down. So now we are going to observe in this diagram. We may observe in the figure. So here in the rotameter we have a float. So that will be moving upward direction. The float will be moving towards upward direction due to the buoyancy and velocity of the fluid. Another force will be pulling down due to the gravity. Another force will be acting downward. So that is about gravity. So gravity pulling the float down. So here two forces will be acting. So one is the upward force, another one is the downward force. Here the float will be moving towards upward direction due to the velocity of the fluid and buoyancy forces. Then another force will be acting downward, that is opposing force, that is about gravity. Due to the gravity that will be pulling down, the float will be pulling down. So this rotameter is also called as a gravity flow meters because there are based on the opposition between the downward force of the gravity and the upward force of the fluid due to the upward force. So this one of the force will be acting downward, gravity flow meters, because they are based on the opposition between the downward force of the gravity and the upward force of the buoyancy and velocity of the fluid. So here two forces will be acting when two forces will be acting, so that the fluid when the fluid flow is constant, the float stayed at one position. So that will be observing later. So here when the flow of the fluid is a constant, when the fluid will be constant, that float stays in one position. That means equilibrium position. stationary position. When the flow of fluid is constant, the float stays in one position. That can be related to the volumetric flow rate. So that position straight away gives the float position straight away give the volumetric flow rate. That means flow rate of the fluid, given fluid or gas or liquid flow rate. So the position indicated in the gradient scale. So here in the construction of the rotameter, so it consists of float, it consists of tapered tube, so that is a vertical measuring tube, and we have a glass graduated scale will be there. So when the flow rate of the fluid is constant, when the float stays in the one position, that is the stationary position, that will be the equilibration. So that can be related to the volumetric flow rate. So that position gives the position indicates the gradient scale. So here we have a tube. You may observe in this diagram. So this is the rotameter diagram, line diagram of the rotameter. So it consists of float. So it consists of a float. Then we have a tapered glass. So at the right side we have a gradiated scale. At the bottom we have a flow inside. At the top we have a fluid will be flowing outside. So the inside of the fluid will be moving in the downward side, and in the top side the fluid will be going outside. So this is about float. So here, so it consists of a tapered tube, that is about glass. Then here we have a float. So that will be made up of a stainless steel, metal or ceramics. Float, it may be the shape of the float will be spherical shape. The shape of the float will be spherical shape. So made of stainless steel, metal or ceramics. So here the gradated scale will be calibrated here. So the float, the position of the float straight away gives the direct value of the volumetric flow rate. So now we will be seeing the working of the rotameter. So whenever the fluid will be passing through the pipe, as a liquid or gas passes through the tube, the flow causes, then the float will be rising. So the float will be rising. So initially the float will be showing the reading will be 0. So when the liquid or gases passes through the tube, the flow causes the float will be rising. So due to the upward force or buoyancy forces, the float will be moving towards upward direction. The float will be moving toward upward direction due to the buoyancy forces. Due to the buoyancy force or due to the upward force, the float will be moving rising upward direction. So one more force will be acting downwards. So due to the gravity, the float will be pulling down. The float will be pulling down. The float is always denser than the substances where the pressure is to be, where the flow rate will be measured of the substances. So here you have to keep in mind, float is always denser than the substances which flow rate will be measuring. So float is always denser than the substances. So here, so when the liquid or gases passes through the tube, the flow causes, and then the float will be rising due to the buoyancy forces. One more force will be acting downwards, that is about gravity. Due to the gravity, the float will be pulling down. So here one position will be, so here two forces will be acting oppositely. One force will be acting buoyancy forces, so another force will be acting downwards direction. In equilibrium condition, one equilibrium condition, when the two forces are equally float will be resting when the two forces are equal. Float will be rest when the two forces are equal. So then the position of the float will straight away gives the volumetric flow rate of the fluid. So this is the concept of the flow rate. So here we have a tapered glass tube. So this is the variable cross sectional area. So this is also known as a variable area meters. The flow rotameter is also called as a variable flow meters. So here the changing in the cross sectional area, changing the flow rate. So here the fluid, liquid or gas passing through the tube, then flow of the flow causes, then the float will be rising due to the upward force or buoyancy forces. The fluid will be flowing, the float will be moving towards upward direction due to the buoyancy forces. One more force will be acting downward direction due to the gravity. So when the float will be in equilibrium condition. When the two forces are equal, the float will be causing stationary. So the float will be resting when the two forces are equally. So these equilibrium condition of the float will be give the volumetric flow rate of the given fluid. So this is the working of the rotameter. So due to the upward forces, due to the buoyancy forces, the float will be moving towards upward direction. Due to the gravity, it will be pulling down. Gravity causes float to fall. So when the float will be in equilibrium condition, float will be resting when the two forces are equal. So it gives the volumetric flow, fluid flow rate value, or rate of flow, or flow rate, or discharge. So as the liquid or gases pass through the tube, the float rate will be rising. So gravity causes float will be falling. So float will be rest where both forces are equal. So that specific level can be read from the scale. So the position of the float, the straight away gives the direct value of the flow rate of the value. So here we have a gradated scale will be collaborated in the rotameter. So this is the construction and working of the rotameter. Now we'll see the advantages and disadvantages and applications of the rotameter. So here we have so many flow rate measuring devices. Now all these flow measuring devices. So the construction of the rotameter is very easy to construct. So that's why it will be using widely using of these rotameter. So easy to construct. So made from the inexpensive material. So it does not require any external source. So here we are not using any external source due to the gravity and buoyancy forces. This rotameter will be working due to the buoyancy forces will be acting. The float will be moving towards upward direction due to the gravity. So here we are not using any external source. Do not require any external force. So it will be using wide variety of system due to their portability and small design. So these are the advantages of the rotameter. Wide flow measurement ranges for rangeability. So here we are using the rotameter. So the wide flow measurement ranges are rangeability. So rotameter scale is also linear. So here any non-linear scale we are not using. The rotameter scale is linear, so that we are using widely in the flow measurement, in the rotameter flow measurement. Then pressure loss due to the rotameter is very minimum. So these are the advantages. So here in the rotameter measurement, pressure loss also very minimum. So due to the rotameter measurement, the pressure loss also will be minimum. So these are the advantages of the flow measurement. So construction is very easy. We are not using any external source. Simple construction. So linear rotameter scale is linear. So with these advantages, this will be using a wide range of application, wide range of measurements also there. So even though advantages, the rotameter also has some disadvantages. So the rotameter must be installed vertically. So in the horizontal, where the horizontal fluid flow measurement, the rotameter is not suitable. The rotameter must be installed vertically with the fluid flowing through the when the fluid flowing through it. So it will be not suitable for in the horizontal position. The rotameter will be placing in vertically only. So this rotameter will be suitable for in vertical positions only. So there is a disadvantage of the rotameter. So another disadvantage of the rotameter is gradated scale is valid only for the specific fluid and condition where it was calibrated. So gradated scale is valid only for the specific fluid and conditions where it was calibrated. So if you changing the fluid, if you changing the fluid, then gradated scale is also will be changing. Gradated scale is valid only for the specific fluid and the conditions where it was calibrated. So if, every time we are changing the every time if the fluid will be changing, we need to change the gradated scale. So the calibration is very difficult. So this is the disadvantage. So another disadvantage of the rotameters. So the made of transparent material. So here we have a glass, transparent glass will be there for gradating scale. So that gradated scale will be transparent. So that made of transparent material. So the rotameter material, glass material will be transparent. So that will be acting. Chemical capability is to be checked for every fluid. So the chemical compatibility is to be checked for every fluid. So here the glass material made up of the transparent material. So that material will be acting. So the chemical compatibility we need to check. So then the disadvantage of the rotameter. So now we'll see the advantages of the rotameter. Now we'll see the advantages. So the oil pipelines, wastewater. So in these applications where rotameter is very suitable. So oil pipelines, water and wastewater, chemical industries, the rotameter is very useful. So the portable rotameters also will be using measuring the flow rate of a large bodies of the liquid or gases. The portable rotameters also simply dumped into the substances. So where the large quantity of water is to be measured, so that portable rotameter will be dumped into the substances. So that will be using these rotameters will be using for applications of the rotameter. So that is about oil pipelines, water and wastewater. So where the flow rate will be going to measure. So these are the advantages, construction and working and applications of the rotameter flow measurement.